Thank you.
Okay.
Was actually me second joining. All right. Okay.
Yeah, it shows record now.
Okay. So, right. So, audio quality of many of the presenters has been a challenge, in some of the meetings I listened to in before. So, if you're presenting, maybe, get yourself a second, audio channel like a phone or so, just in case the inline audio doesn't work. Make sure your video is off normally. If you're presenting, please feel free to have your video seen by the others. I think that should still be perfectly fine from the bandwidth requirements, and otherwise I think people can chime in on the chat if they are having problems with reception bandwidth. Typically it's the sending bandwidth. Right, mute your microphone unless you're speaking. We may mute you if you're kind of not noting that you're causing problems. And so before you're speaking, please check that you are unmuted. The WebEx chat is only for the Q&A and questions. So every one of the presenters, please indicate when you would like to be interrupted or not. Typically, I guess, if somebody doesn't say something, we'd do it at the end of the presentation. And I'm just looking at I'm checking the chat on the second screen so that we know when somebody wants to say something. The Etherpad.
Here is.
Yep.
Are you sharing your screen?
Oh, wait a second. Is it not?
We are seeing your face, but not the slides.
Okay. Okay, thanks for the reminder. Let's see.
You. Maybe you turn off your camera.
So, share screen. Yep. So should be shared now. Sorry. Thank you.
Yeah. So suppose.
Yeah. Yeah. This was also the outcome of joining from the second notebook. I apologize. All right. Etherpad. The logistics is there. The agenda is there, and so I'm just bringing it up now. It's not shown yet. I think there is some delay. Oh, that's not good.
Starting sharing, but
I'm sharing the screen. I brought up the Etherpad, but I'm seeing on my second notebook that it's not.
We see virtual logistics. Now we see your face. I would just leave your camera off, and now you're muted.
Okay. So let's start to share again. Screen. Okay, so I'm switching video off. Let's see if that helps. So here is the Etherpad. All the same logistics that we said, agenda we're going through. And please, just in the normal IETF blue sheet, please add yourself to the list of attendance in the Etherpad. You know how it works. If we don't have a long list of participants, the virtual meeting room will be smaller next time.
no, well, I haven't seen your screen yet.
So I'm seeing actually on my second notebook that it is without sending video is now fairly quickly following me changing the different screens. You should now be seeing again the virtual meeting logistics.
Yes, it's there.
Okay. And any form of discussions, please on the Jabber room and not on the chat. So that's the virtual meeting logistics. If you have any questions, please feel free to chime in here during the chair slides on any of the logistics, so we'll make sure that everybody can participate well in the meeting. IETF Note well, I think you're all aware of this, and it applies equally to any of these virtual interim meetings as it applies to the in-person meetings. So unless you step out and go to the hallway Jabber, everything is meant to be public and all the BCP applies. All right, so, and this is back to the standard slides. So we primarily need a minute taker. So can we have anybody chiming in here? Shane, did you look up for anybody who we could have do that?
I did volunteer.
Volunteer? Okay, excellent. Thank you very much, Michael.
I'll just say that there's only 3 of us in the Jabber, not including any chairs.
Yep, I'll join to the Jabber as soon as I'm through with the chair slides, and help there as well, and the Etherpad. Right, so we've got the slides, we've got the WebEx, so I don't think we need a Jabber slide, Jabber scribe, given how the presentation needs to be so that everybody remotely can follow it anyhow. Okay, so standard chair slide deck. So here's just the list of working group documents. We're just not going to do a lot of it today. I'm going to give an update about the autonomic control plane, which is the pretty much the last one of the slide of the charter documents that we're hanging on to, and that will be at the end of the session now, because the IESG telecall is still on the first hour, so Eric Winke can only join in the second hour. So then for the bootstrapping key infra, so Michael said no need to do slides. It's almost fun. Michael, do you simply want to jump in with 1 or 2 sentences?
I read an email that said that asked the Secretariat to publish from the ISG this morning.
Excellent. That's a great success. Thank you very much for all the hard
So
work.
maybe at 9 a.m. when they wake up, 9 a.m. Pacific when they wake up, they'll push the button, and I guess it'll happen.
Cool. Great. So for next time, somebody has to figure out how to do the virtual champagne. And yeah, and then of course we have the poor documents waiting in line. So we had some discussion with Brian about the dependencies, but let's take that, I think, after this virtual meeting, if we need to change any of the strategy on how we're dealing with our cluster here.
One question, Michael, do you actually have the dependency to the ACP? I mean,
I believe that I would have to double check if it was a normative or informative, but there is definitely a link to it, to ACP.
Okay, if it's normative, then you may join us for the waiting for ACP. Hopefully that will come next month.
Yes, I'm pretty sure it is normative,
Okay.
and I believe we're in the second IETF last call, but it's already been through IESG, right? So,
yeah, I'm going to give that update in the ACP presentation. Yeah. Sorry, just wanted to start taking notes for the administrative stuff. I need to follow up with that too. Okay, so the one slide we never gave, but which seemed to be good. So that was coming from me stealing slides from another working group. For those folks who have recently joined and started to work within ANIMA, we do have a GitHub. URL is there. It's very informal. I'm not sure if IETF has any more formal things about GitHubs right now, but I think, and Michael started this GitHub, so he may want to chime in, but I think we'd be more than happy to have any, additional work that people feel relates to ANIMA, whether it's a working group document or else, software, anything related to it, use that GitHub. So please simply reach out to the members of the GitHub to get added to it. Michael, any more insight?
it's probably lacking some of the predates the GitHub how-to, and we certainly aren't using it consistently across drafts, but it's, I guess, I think it's got all the right pieces. You guys have control, and Rob Wilton's in the queue. Are we doing queuing? Are we doing queuing in this working group? Is there enough of us?
Yeah, Rob, please chime in.
Yes, so I was just on the GitHub stuff. There is a couple of drafts that have just gone through the ISG on GitHub. One is configuration guidance for Secretariat set it up. There's another one on guidelines on how to use GitHub with choices. the working group in terms of how they want to manage projects in GitHub. So it might be worth having a look at that draft and seeing if there's bits of that you want to adopt for either general process or for particular drafts. But I think it's up to the working group to decide exactly how to do it. They're just recommendations. On the question as to whether you need to use the queuing or not, that's up to you. If there's not enough people, then don't stand on formality.
Yeah. So I would also say that maybe I'll just say I'll raise the need for the queue as soon as I see too many people are talking at the same time. So please chime in whenever you want right now. Yeah. So I guess we'll just stick to be informal here, and then somebody will hit the chairs procrastinating on reading the GitHub RFCs, and so then we'll do that and become more formal. Okay, so here is the agenda. I think we may be having to skip one document. I think I was missing one slide deck in the morning, but I think we can take it offline for the moment. We have some decks in before. And yeah, that's the end of the chair slides. Any more agenda bashing, additional items you would like to discuss? Going once, going twice. All right. So let me find the first thing, which is Brewski AE, and bring that up, and I can drive the slides. No.
Should be the PDF.
Oh, should be the PDF, right? Okay. And here we are. View full screen. Okay, and please tell me things like next slide or so for me to move on.
Okay, perfect. So would like to give an update on the Brewski IE draft, which is currently in version 03. And the co-authors are Henrik Brockhaus and Elliot Lear. And you can go to the next slide. So the next slide basically describes the problem statement, which has been also discussed during the last IETF meeting. So the draft provides an introduction about different industrial scenarios, which may have problems with the current approach that is described in Brewski, because there are some situations where we have limited online connectivity to backend services, like a PKI, which is used during the onboarding or enrollment. Or there are sites which assume only limited on-site PKI functionality, so like an LRA instead of an RA, where the a local registration authority, while the RA and the backend performs the final authorization of the certification request. New in this draft is the introduction of a scenario where we have limited connectivity to a registrar, and I will come to that one later on. The main contribution that the draft provides is to utilize authenticated self-contained objects for the certificate enrollment, more or less in a similar way as being applied for the voucher handling. And the intention is to be transport independent using that approach. So next slide, please. So the changes from version 02 to 03, there are some smaller changes, like the update of the terminology used. So currently we use self-contained objects or authenticated, and authenticated self-contained object is basically the object we are targeting. The intention is to say we have an object that provides proof of possession and proof of identity. That is explanation we also use in the draft. The naming is more or less out of the box, so we can also think of alternative names if authenticated self-contained objects is too long or too awkward. We could also use something like attestation object. There are some editorial improvements. I simplified the picture that we have for the initial use case with an offsite PKI to avoid showing complexity in the offsite PKI, like an inventory management or something like that. And the main part, or the main change from 02 to 03 version, was the introduction of the new application scenario using also the approach of authenticated self-contained objects for situations where we don't have an online connection to a registrar. So this requires some changes in the call flow sequence. We may need to discuss some trust relations or trust assumptions that we have for that. Right. So you can go to the next slide then. So this is basically a repetition. The notion of asynchronous asynchronous enrollment utilizing authenticated self-contained objects basically relates to, we would like to have objects that bind the proof of possession of the private key, like we have in the normal PKCS10 or the CSR. And additionally, the proof of identity to be transport independent. In the current approach, it is not ruled out in Brusky to use EST with full CMC request, but what we address here in Brusky RA is to be able to utilize different options of existing enrollment protocols or utilizing even other enrollment protocols that provides this self-contained feature. So what we in addition need is some kind of certificate waiting indication if the contracted RA or the registrar is not able to issue the certificate at the same time when he gets the request. So the document basically lists the different requirements for handling those self-contained objects. And the intention is to be agnostic regarding the actual enrollment protocol. That's also one reason we utilized the well-known naming to enable other enrollment protocols in the same way like we have it right now with EST. So the next slide is also some kind of repetition. Sorry for repeating some of those things, but we moved the main scenario that we had in the draft so far to use case 1. This use case 1 describes the offsite PKI components. So it's just a smaller change in the original figure of Brusky, where we basically ripped out all the PKI components and put them in the backend domain or in an offsite domain. And there is a connectivity to the onsite domain, but that may be only temporarily available. So in that respect, we would need some kind of possibility to store certain information on the domain registrar and deliver that later on to the PKI. And the PKI itself needs to be able to make some authorization decisions. So there would be a need to have the initial identity and the initial authentication information of the pledge when onboarding the new domain available also in the offsite PKI. So that is the approach where we use those authenticated self-contained objects. Right, period. So if we go to the next slide.
Just one quick comment, right? So it would be nice in the graphical thing to have a little bit more distinction between what are online communication protocols versus offline steps taken of communication. I guess the dropship is well, yeah, not quite clear where the offline stuff, right? So the difference, because this picture looks pretty much the same as from Brusky, right?
Right. So the difference is that the rectangle in the original document comprises not only the join proxy and the domain registrar, but also the PKI. And we ripped out the PKI here and put it underneath as offsite domain components. And the offsite domain components comprise the registration authority that is performing the final authorization of the certificate signing request and also the CA. So the domain registrar would more or less act as local registration authority.
Right.
But we can
no, without repeating the original picture, maybe there's just a little bit more visual hints to give what the new part is here. Yeah, thank you.
Okay. Taken. So on the next slide, that is the second use case we just introduced in the recent version of Brusky AE. That is the case where we have the pledge not directly connected to the domain registrar. So there may be different reasons for that. One might be that the pledge doesn't have a connection yet to the domain registrar. Another reason might be that there's a different technology stack, but that technology stack would also use certificates for authenticating the pledge in the domain itself. So what we introduced here is a pledge agent to decouple the pledge from the domain registrar. And an example scenario might be if you have something like a building automation network and you have certain installations of fire detectors, fire sensors in the basement, and there is no connection yet to the domain registrar, which might be part of the rest of the building automation system. So the service technician more or less would go to the seller, fetch the different information necessary to onboard the different pledges. So the fire sensors, like the voucher requests and the certificate signing request, and stores that on the pledge agent. And then as soon as he has connection to the building automation network, he can forward those information objects to the domain registrar for further processing. And then once he gets the answers from the domain registrar, he can step back to the seller or to the basement and provide the information to the pledges. So that is that also would allow for a bulk onboarding of devices. So assume that in the basement where you have no connectivity, there is not just one pledge to be onboarded, but a couple of pledges, so a couple of fire sensors basically. Okay, so in the next slide, we have the potential call flow, the potential changes that we discuss in the draft. So on one hand, we introduce the pledge agent here, and the assumption is that the pledge agent talks with a domain registrar and utilizes the typical Brewski approach. So he can find the domain registrar using the same discovery mechanisms, and he has a connection with the domain registrar, which is also secured by TLS. So the communication between the pledge agent and the pledge itself may be, from a transport perspective, be vendor specific. But the information objects that are exchanged, those are to be standardized. So the information objects here are the voucher request, which is already part of Brewski, and also the certification request. What needs to be done by the pledge here is to trigger the pledge to perform certain operations. So that is why we also call that the push model. So the pledge is pushed to create a voucher request. We have a discussion, if it is necessary, that the pledge agent provides a proximity certificate from the domain registrar already to the pledge at that point in time. If he does, then the pledge can insert the proximity cert already in the voucher request. Then the pledge would be triggered to create a certification request. Optional here is the delivery of attributes for the certification request. Then as soon as the pledge gets this information, he can basically build the communication up with the domain registrar and then forward the request to the domain registrar. So this is one difference that we have introduced here. So the intention is to have the pledge agent as agnostic as possible. So that means in the current model, we are not expecting that the pledge agent utilizes an IDEF identifier to authenticate towards the registrar. So that this type of authentication might be done by utilizing something like an authentication on HTTP, for instance, of the service technician or of the user operating the pledge agent towards the domain registrar to basically authorize or provide an authorization option for onboarding devices based on the pledge agent. So I just put in a TLS arrow in there because all the information exchanges that are being done between the pledge agent and the domain registrar would follow the Brewski approach. And as soon as the pledge agent has the necessary information, that means the voucher and also the certification response, so the certificate, he would provide that information down to the pledge. The pledge on his side can verify the voucher. As soon as he accepts, or as soon as he could validate the voucher, he can accept the domain registrar certificate as trusted certificate on his own side, and then validates a certificate that he got from the pledge agent. And if both is done, he can provide the voucher status and also the certificate confirmation, which can be fetched by the pledge agent and then provided back as a telemetry option that Brusky provides. Okay, I see that Elliot is lining up there. So from my point of view, we can take questions in between, so that's perfectly fine.
Good afternoon to everyone, and thanks for presenting this draft, Stefan. The only comment I wanted to add was that mostly I view this draft as being more about EST than about Brusky, and so it's a slight misnomer in my view. But other than that, I see this as a good extension to make Brusky a little bit more robust, and EST a little bit more robust, because not only will these requests have to occur during registration, but of course they'll have to occur if the certificate's about to expire or for maybe other reasons as well. So
yes and no. So yes, in the context of, I'm sorry? Hello?
We like the word yes.
Okay. Yeah, sorry, my connection here. I have a more or less narrowband connection, so I hope everything that I said so far came through. Anyway, I think it's not just a pointer to EST here to more or less specify the full CMC or to specify the full CMC request as part of EST. It's also the change of the sequence in Brusky by fetching the voucher request and the certificate request at one point in time and delivering both at a later point in time. From the call flow, I don't think that this really disturbs anything of Brusky. The only thing that I think is a matter of discussion, how do we authenticate the pledge agent? Is there a necessity to have an authentication there? Or can we simply rely on the authenticated self-contained objects that are exchanged between the pledge and the domain registrar? Okay, so we could go to the next slide then.
I have one question. With this being very specific to, let's say, EST, maybe Brusky, right? So whether or not you want to adjust the name, that kind of is what I heard implicitly from, I guess, what Elliot is saying. The larger question to me is, is other principles in there that, go beyond applying it explicitly to, EST and Brusky, because, we already have alternative protocols in the IETF like netconf 0.
Yeah.
So, yeah.
Very good question. So the intention that we had with the first use case was to open up the possibility to also utilize other enrollment protocols. And that is reflected in the adoption of the well-known scheme to basically allow other existing enrollment protocols in there as well. So that could be CMP, CMC, or it could also be the approach, I'm not quite sure how far advanced that meanwhile is, to utilize OSCOR for certificate management.
Right. So the problem really is that we don't have a clear, separation in our naming so far between Brusky, the protocol, and Brusky, the kind of architecture, right? So we call everything Brusky, and maybe, one of those naming issues to solve through, right? That this is to a good extent, then, as you say, more about this whole bootstrap architecture as a Brusky protocol itself. But, I'd like to leave it up to, somebody like Michael or others to come up with, maybe suggestion how to unconfuse our naming.
Yeah, that would probably be good if, right now, if the Brusky RFC will come out in the next couple of days, hopefully, then the name Brewski basically reflects the overall protocol approach here, not just that's my understanding. So basically the combination of the voucher exchange with EST or with an enrollment, let's call it that way, with an enrollment. And actually,
I don't think that's entirely true, right? So something like, you could easily, build a Brewski architecture solution with netcon, zero touch, for example, but that's not covered by Brewski, the protocol spec. So that's where I'm coming from.
So I guess what I would suggest for this is Elliot. I apologize for interrupting, and my network is a little flaky, so please bear with me. Is that I think what Stefan has proposed here is actually it's a pretty good architectural capture, if you will, of the issue, and he's given very specific guidance in a couple of cases. I propose that I know I'm jumping slides on Stefan here, but I propose that the working group adopt this with the idea that if there are other examples that need to be identified and included, we just do that as part of the development of the draft.
Okay, let's go to the next slides, because I'm just starting with the discussion and the open issues, and that is obviously one of the questions that we need to ask there. So so some of the questions may already be very specific for the use cases that are described there. So one, we probably don't need to answer that question right now. So one is the pledge agent authentication authorization issue in use case 2. So the intention actually is not to require the pledge agent to have specific credentials. So you can think in the easiest form, you can think of the pledge agent as something like an app that you have on your mobile phone, for instance, to allow for onboarding. And the mobile phone may talk, for instance, Bluetooth to the pledge and IP to the registrar. And if there's only the information object described, like the voucher request object and the certificate request, then it's fine to have some kind of end-to-end security by sticking that to the information object exchange. What would be interesting if the thing that I mentioned, that the service technician that does the onboarding has some kind of authorization that he shows towards the registrar, but this can be done by using user authentication, basically. This is something that we can discuss in the draft. So there are it is already named or stated in the draft as question or as proposal. But this is something that probably needs more work. There is a second question connected with that. If we provide the proximity registrar certificate to the pledge from the pledge agent. So if we do that, then I guess we need some kind of additional authentication by the pledge agent, that the pledge knows that he's talking to the right agent. That is what I would expect there. And this type of authentication may make the pledge agent a little bit more complex. So if we assume that the pledge agent is coming from the vendor, then the pledge could probably authenticate the pledge agent very easily by validating a certificate if it is issued by the same vendor CA. But if we think on something like a universal commissioning tool that may onboard the pledge independent of the vendor, then there would be some steps necessary to equip the pledge agent also with a kind of credential that can be validated during the onboarding by the pledge. Again, those two questions, I think they are more related to the further proceeding of the draft then. So on the next slide, we have the addressing scheme. Right, so this is what I mentioned, Turles, as you asked. So the we basically leverage the notion that with a well-known approach or with a well-known scheme, and we currently have the notion of well-known / enroll protocol or enrollment protocol request, and the proposal is to change that to well-known and then just enrollment protocol and leave the remaining part of the addressing to the enrollment protocol itself. So EST has some notion of that. There is some further notion in the lightweight CMP draft, which also provides utilization of the well-known scheme there. So therefore, we would just state enrollment protocol and not any specific commands that are to be executed by the domain registrar there.
Yeah, thanks. That goes way beyond the level of detail I'm currently grasping. I think that this is probably fine for Bootstrap. I guess for me a little bit the question is how would this go further on into something like ACP, where, for example, for certificate renewal, we're currently mandating EST as the mandatory to implement. And so if we basically broaden ourselves beyond EST, I'd have to think about how that trickles over to ACP extensions as well, I guess.
So I think that in a lot of the use cases that Brusky AE is addressing, I don't think there will be an ACP, at least on the initial thing for the case of the rail cars and the housing construction. It seems unlikely that there will be an ACP when the devices are provisioned. There might be one later. And I also think that the certificates that are provisioned, the LDEV IDs that are provisioned into, say, a home, would probably have a 2 to 5 year validity period, with the assumption that when the first owner takes possession of the keys of the house, and this is both literally and figuratively the keys, that they would then rekey everything, because that's what you do when you buy a new house, right? You change all the locks. And so that now they would then provide some EST or CMP renewal function when they essentially restarted their home controller with a fresh factory defaulted thing, and then provide the keys, and then it would take over getting rid of all the construction companies' identities out of it. Does that make sense, Stefan?
Well, it definitely makes sense to remove the word CP and replace it purely with how about certificate renewal. And I could start complaining about my TiVo again, which doesn't have certificate renewal, so all the certificates are expired. And I don't think that re-enrollment, which I think I heard you saying in a period of 2 to 5 years.
No, not enrollment, not re-enrollment, rekeying.
Okay. But that also would then have to basically be, understood to be required to use exactly the same protocol that would be used for the initial enrollment. If we go in,
but that enrollment could also signal that the home controller, the one that the owner has bought, saying, yes, I have to re-enroll the furnace with CMP and the refrigerator with EST, at which point I'm letting them both know that we're doing X. Okay. Or it's going to have, or if the devices don't support X, then it's going to have to keep using the one that it was enrolled with, and the controller's got to speak multiple protocols, and that's just tough because the industry couldn't decide.
Well, let me just say that, I inherited a lot of pain trying to specify all the certificate rekeying renewal for the ACP. So if we go further on, and especially saying there is no ACP, and we don't, specify those pieces here, then, these solutions will not work after the point where rekeying would be required. So I'm not sure if.
So let me suggest that an industrial association like the Building Association may write a document similar to the ACP document that specifies how that works, and that if I bring a commercial fridge to my home, that I may have the problem that the commercial fridge consortium decided on a different protocol than the home construction consortium, and I have to do something magic, right? And that may be intentional market you know, what is it called when you split up the market? Yeah, there's a word for that. And that may be intentional, or that may just be the where they each went. But I think that for the moment, I think that that the enrollment specification is not that complicated to write outside of the space of the ACP. You just needed to write that part. It's not that complicated, but it might be that Brewski AE doesn't need to specify it itself because it's better done in an industrial document.
Of course, no, but I think that what would be good to say is if you want to build in this document, if you want to build a solution out of that, there is a dependency adopters need to specify, which is kind of the rekeying after the initial enrollment, right? That's how I understood you.
Yes, that's what I said.
Okay, cool.
So just to give an example from a different domain, in power system automation, for instance, there is also the case that the infrastructure needs to support two different enrollment protocols, because there was a request to support different enrollment protocols for, let's call it, historic reasons. So one is SCEP, the other one is EST. So we ended up in a situation where the infrastructure has to support both enrollment protocols, while the pledge, or the enrolling entity in that case, can choose. It's not nice, but that is a compromise that was taken there.
So this is all a lot of fun, and hopefully we can take the discussion to the list. But unfortunately, the working group chair, woke up in me again and looked at the clock. So.
Okay, sorry for keeping the discussion running. So that's the last slide. So it mainly describes the next steps that are envisioned with the draft. The goal is to reuse the Brewski architecture elements as much as possible, and just to adapt, for instance, the sequences from the Brewski document, but reutilize all of the different elements. We currently work on a proof of concept for the use case 2, together with a pledge agent. And the last question is basically the question that Elliot was raising before: is the working group in favor of adapting that work as working group draft?
So yeah, so I don't think, has anybody actually seen good experience with trying to use the raise hand thingy here in WebEx for, if you're doing, want to do an adoption call at least. No, I'm not sure if it. Michael, have people
Can we put this another way? This is Elliot. Toros, my suggestion, this draft's been presented several times in this working group. And maybe the way to do this is a negative request, which is, does anybody object to its adoption at this point?
I don't know can we take this offline, because the process is much better than I do. I would definitely just do a normal adoption.
That's the consensus question. That's what the consensus document says you should do.
Okay, can we take this offline? Just as a process, I was just checking beside, obviously, an appropriate adoption call on the list, which we must do anyhow, whether anybody has seen a useful way to poll the virtual room here on WebEx. If not, then let's not try to do this now. There is the raise hand in WebEx, but I haven't seen people trying to use it successfully. That's all I was saying.
It's Rob here. So no, I don't think there is a good way of polling on WebEx at the moment.
But I think that's also fine to do that on the working group list. What I sense so far is that there is an interest to further work on that issue.
I also think it's fine to actually ask the question here in the meeting if there's anyone opposed to adopting this, just to see if anyone is. I agree it still needs to be taken to the list regardless, but it seems like a valid question to ask.
Yep. Please chime in now or later when we're on the list. Okay, so let's move on to the next agenda item. I think that would be information distribution. I think I just saw it already. Would the presenter please step forward and take the mic?
Can you hear me?
Nope. You need to bring up the level a lot more.
Now can you hear me? Is it
Yep.
better?
Yep.
Okay, great, great. Hello everybody, and good morning, good afternoon, and good evening. I just present a very brief and short administrative update.
You're
of
fading
us.
out. Also, could you please introduce yourself? It's not clear which authors.
I'm Xun Xiao from Huawei. I'm also the one of the working group draft. So now today I just present a very short and brief administrative update about this draft. So you can go to the next page, please. Yeah, so this is just a short recall about the content of the draft. Again, we are focusing on our new module to provide the entire information distribution functionality for the ASA. And also, this draft also consider some possible or necessary extension about our RAS protocol. Yeah, so here the green boxes are our focus in this draft. Okay, next page, please. Yeah, so here basically summarize the major change that we made since adoption. So first of all, this draft was adopted as a working group document in this library. And after that, we immediately provide a 0.0 version, although we didn't provide any too much technical update. The major change of the draft is that we basically collected all the comments that appeared in our mailing list, and we summarize into the following three categories. So the first one is that some reviewers or ANIMA suggest that we should put more references to the use case into the introduction part, and probably we better position with the content and our requirement in the context of the connected card. Probably this is a more suitable use case to illustrate what are the main technical point of this draft. And also we can consider some use cases from the firmware update and so on. So this is the first category. And also the second one, we were suggested to rethink or refine our terminology, which we quite agree, of course. And we should also somehow better align with those pre-existing terminologies that are already used in the other ANIMA documents. So we will also do that. And the third point is that we should also provide more protocol behavior description. Probably we put too much about the implementation part. For example, what kind of API messages or parameters must be extended in order to support our proposed functionality. But we focus a little bit less on the generalized description about the protocol behavior. So we will also do that. So yes, so basically this is our major change about the very initial version of the working group document. Okay, please go to the next page. Thanks.
Just quick audio check, right? So can you try to make sure that you're not breathing that much into the microphone? Just can keep it steady at a good distance and not too close. I think right now you're holding it too close, but try to keep the level up.
Okay, is it better now?
I think you need to always talk a little bit longer before we hear whether you're breathing into the microphone, but the level is a little bit low. Sorry for that.
Okay, no problem. Okay, no problem. So in general, we will of course we will of course gradually address all the collected comments and provide a new version before the next IETF. And we are also partly planning our kind of very simple prototype to implement such a proposal in order to at some point demonstrate our proposed functionalities. Yes, we are still in some discussions. Yeah, that's all. You can go to the next page. So again, thank you very much for the support about the adoption. We will keep working on that. Yes. From my side.
Always remind the working group that this work is going on, and if there were last time any open questions or now, just remind in mail so that people will continue to respond. There is always things falling over.
Exactly. Thank you.
If there are any questions, please ask them now. I'm trying to already get prepared for the next one.
There were no questions about that.
I didn't hear any. Okay.
Yes, I'm here. Can you hear me?
Yes. Is that you? Please introduce yourself.
Hello, can you hear me?
We can hear you. Can you hear us?
Yeah, yes, I hear you are speaking, and my name is Jie Yang.
Yeah, please next slide when you want to move on.
Yeah. Okay. Let's begin. Hello, everyone. Yeah, and okay, let's begin. To enterprise customer, S3 has already been standard deployed solution. Meantime, during the network deployment for higher reliability to service continue, they usually design multiple and redundant network link between devices, like the right to case. But the ACT is IP-based architecture, so there lead some challenges in creating ACT in their two SD network. Next slide. Next. Hello.
I already see the new slide. Maybe it takes a little bit for you to show up with you.
Okay. Next slide. Thank you. And based and RFC 8368 using ACP to provide a stable SD connection. But before finishing the connection to enterprise campus network, it is layer 2 system. So broadcast traffic will make loop in this network, like the right figure describe to host X broadcast traffic. One loop will be made between switch A and switch B, so need to deploy loop breaking mechanism. Traditionally, STB is famous, but because STP complicated top calculation, so the layer 2 network convergence very slow for large network automatic configuration, especially during onboarding, is not good solution. Meantime, STB may miss some device or may discover untrusted devices. This will cause terrible problem. Next slide.
Click.
Next. Yeah. So we think we think about layer 2 based device discovery protocol and is standard in IEEE low lead control plane to calculate LDP protocol. Importantly, LDP only receive packets and does forward them to remote. LDP packet is only between switch B and switch A, but by this, LDP doesn't cause loop network and about LDP frame forwarding plane already send them to CPU. This is ACP design behavior. So we can combine ACP and LDP together. Next. Next slide. Hello? Yeah. Okay, thank you. And for layer 2 based SDN, every legitimate switch must be discovered. Even exist multiple layer of layer 2 connectivity, like the right figure, and must avoid including any system into top. For example, desktops, because this system may have malware and pretend to be a router. Meantime, because this is autonomous network. So when power on, new switch need to be discovered automatically. And whenever something changes, the discovery need to be continuous too. Okay, next slide.
I think the animation is running now.
Next. Yeah. Next. Yes. New system. Yeah. Next. Okay. This is, and then to achieve ACP inside LDP, there are many the following process to do. Firstly, encapsulate IPv6 into LTP TLV system. Then, after receiving LTP packets, ACP will enable manually ACP adjacent table to finish device discovery. Once new switch is on board through Brisky and by the help of join process, new switches will be discovered. Next slide. Yeah. Here we discuss. So we need to discuss LDP encapsulation. Let's see as the left figure. Okay. Return.
Something happened to sorry with the I didn't do anything. I didn't touch the notebook. Sorry for that.
Okay. It's right. And let's see LDP frame pharmacy, LDP PDU, LDP DU is in the data error, including the TLV header and IPv6 packet information, because the TLV information string in LDP frame pharmacy has the limit of 508 octets, but meaning IPv6 M2 is 1280. So IPv6 payload needs to be fragment. That is to say, LDP IPv6 fragment contain more than one TLV. This TLV include two points: sub-TLV type and sub-TLV content. Okay, next.
Click.
Yeah. Okay. First one is is TLV type, sub-TLV type. To one IPv6 packet, multiple TLV use different subtype TLV value, or repeat the same subtype TLV value many times. There are two this solution. To option 2, need to design how to keep multiple TLV with the correct order. I think this is more difficult to achieve. And the second is issue is about content payload. Every fragment encapsulate entire IPv6 packet, including IPv6 header, or elide the IPv6 header and other by hard code, or compress them by mature RFC or other technology. There are 3 option solutions. Which solution is preferred? Need to compare and analysis more. Okay. This is our draft idea. Hope ANIMA can act as work group's draft. Thank you.
Any questions?
Robert, so I just have a question really about whether this overlaps in the mechanisms that IEEE already defines for sort of connecting switches together. So my understanding is like .1Q, .1AD already have some ability to self-discover devices and self-configure themselves.
Can I ask a question, Rob? Do they include enrollment and IDEF ID based authentication?
The answer is I don't know. I would be surprised if they did. I think my question is more about whether we should be trying to speak to 822.1 working group to see if they have work in this area or if they'd have any concern with what we're doing here, or maybe that doesn't matter. My just thought is if they already have a mechanism for doing this, is there something that we can piggyback on rather than potentially reinventing the wheel? It's like a different way.
That's a good question. I think ultimately we're trying to run V6 over a hop by hop protocol, avoiding broadcasts or multicasts.
Okay. I mean, I think it's
so the easiest thing to do to answer that is probably to send a email to the coordination group between the IETF and IEEE 802.
Nice your badge on the WebEx. Who's talking?
Russ Housley.
Thanks. Sorry, go on.
So the simple thing to do is just send a note there, and if there is a need for a formal liaison or something like that, it's easy to put together, but we'll find out quickly whether that is needed or not.
That's a great idea.
Russ, am I right in still thinking you'd share that? Is that right?
Yes, I do.
Thanks.
Good you know about it.
There are no more questions on this next presentation?
Actually, Michael, I put myself in the queue. This is Eric Vink here.
Oh, there. Sorry, I overlooked that. Please.
No problem. About IPv6 over LLDP, this is kind of interesting, of course. But my understanding is that LLDP is not indeed forwarded by switches, not based on the fact it's LLDP, but based because the destination MAC address is a very specific one. So of course, a lot of things need to be synchronized, like Russ say, with IEEE. But my understanding is that we do not need to get a specific encapsulation in the TLV there. Because the trick is not LLDP, the trick is the destination MAC address. To be confirmed, of course, and to be confirmed whether it would be working like this.
I think what you're saying is that we could get the same effect with a specific destination MAC address and without the same ether type. And if that's the case, then we could try something else. But LLDP itself, however it gets there, gets up to the control plane, and that's actually the property we really want. It bypasses all of the forwarding mechanism in the forwarding plane ASIC and goes straight up to the control plane. And we're really, which means that we're completely divorced from however configured or misconfigured the ASIC is. And so we always get the out of band channel that we want, or the in-band out of band control that we want for the ACP. Does that make sense?
So let me also make a suggestion here, right? So it would be very good, and I think to me, you know, as an individual contributor, that would be my suggestion, to have a comparison of this mechanism with the ACP over or for L2 switches that is in the ACP document itself, right? Because that basically is an existing solution option, and I think every reader would like to understand what the difference in benefits are of this approach. Okay. Are we done? All right. And I think we're up for delegated authority for bootstrap voucher artifacts.
Okay, thank you. And okay, and another draft about our team is delegated authority for bootstrap feature. And the next, okay, in Brisky architecture, manufacturers feature format based on RFC 8366 and require a MASA system to provide a feature for every device. Usually, this MASA is manufacturer's original service, mapping the device dev ID. Later, there are no change to another MASA. So this block secondary sales mostly. Brisky need must be reachable to register during onboarding, and the device owner is strongly trust the MASA service. For some offline cases, although SDB can work better, but it doesn't resolve resale issue the same. Next. Yeah. Second sale exists many cases. For example, due to creditor or bank reputed, manufacturer device transfer to winning seller later. Another example for a cloud or public KPI, the register we wish to change its CA at some time. This is resale. Like this slide diagram, the bottom blue register must override MASA URL, contacting green registry for feature. Here, the green register is a delegation authority. Next slide. Yeah. And further, multiple resale solution also exist. Like this slide diagram, new pledge need to receive 3 purchase with the order chain. MASA is delegation 1, D2, then resale 0. From real operation, resale can't be forever, so may need to limit resales number. This is multi-resale. Next. Yeah. Another delegation feature scenario is assembly. Like this slide diagram, assembly control is so manufacturer's feature should serve as delegation options. Like this, play and 2 MASA. Okay, next slide.
Click. Some
may be transparent, like diagram. Firstly, require assembly on board. Normally, get is yellow feature by the order step 1, then step 2, and return back feature on step 3. Secondly, assembly act as a device to reading register. Then the page feature by the step 3, step 5. This is transparent assembly scenario. Okay, next slide. list. Yeah. So for resale and assembly scenario, we propose to shape current feature model. The upper is the standard feature, and the bottom is our proposed solution. Like this, as you can see from this slide, we can see we hope to extend the delegation CA and add the flag whether the catcher is delegated or not, and if it be delegated, need give the intermediate identity and the delegation times. Next.
Click.
Yeah. And in our draft 0, give the related proposed intention about delegated feature, like the yellow mark. Okay, here Article 4 and here we give our issues about delegation feature is extension terms, whether is right or not, and the other, because the feature have changed, so the pledge and the register may be enhancing. And here we give 3 issues to think about, and ask for ANIMA to review whether it is valuable for or not. It's okay. Thank you.
Yeah, Stephen. We're in the queue.
Yeah, I should the mic. Sorry, this is Stefan. Yeah. Just going back to the slide where you mentioned the third scenario with the transparent assembly. Just from my understanding, this would basically resemble the functionality that was described in this marker cling draft. Is that the same approach?
Can you say stop? If you want to see the slide and I should do it, can you say stop? What number?
That's
One,
right
yeah,
slide.
no, the one, slide 6.
So I am not sure that smart tickling would apply to this, but maybe because this still assumes that the mass of 4, like we could still do Brewski AE for mass of 4. We could do smart tickling for mass of 4, but for the way in which the 1, 2, and 3 ducklings are onboarded to the rail wagon registrar is strictly local, because the green registrar, acting as a delegation authority, issues those pink vouchers.
Okay, understood. Okay.
So that's because everything's local is localized. So I agree that it's similar, but and I hope it's clear that you could have multiple layers of this, so that blue-ish registrar, the rail wagon registrar, could be then doing this with the train, right? The next level, or whatever number of layers of encapsulation you have. But at the end of the day, all of the parts are in fact registered to whatever the highest level registrar is. There's not layers of registrar. They're flat on a network. I think that's the goal, right?
Okay.
So we could in fact have secure communications between left front brake thing on bogey 1 with left front brake on bogey 2, and also the one at the back of the train, if that's somehow made sense.
Okay, that clarifies it. Yep.
Anybody else in the queue? think 3 times the charm. If you're already talking, you must be muted.
Can you hear me?
Now we can hear you.
Okay, sorry. Here, and here, let's present our third draft again. The draft is give full operational consideration for next consideration. Next.
You didn't want to say something to the reference slide number 2? I'm on slide number 2, reference of Brewski Register Connect.
Can you hear me? Yes. Yes.
Maybe you don't want to look at you know what you're seeing in WebEx, but I'm telling the slide number, you know, locally the number. Mm-hmm.
About register's architecture. And the first is Brewski's implement the domain and authorizing. Let's open the register. Internal structure. It has around common database. Nodes in funds connected with Masa, and the southbound interface connected with Pledge, and web-based management interface and optional CA. Correspondingly, PKI recommendation database process and IPv6 collect address to Pledge and LAN security. We think need to discuss deeply. Next.
Yep, I'm on slide 3 now. Please talk to it.
Yeah, this is our this is the first consideration for register. For different cases, depending on the network scale or enterprise type, ISP network usually deploy multiple lock in different locations. So they practice with three type PKI structure due to register lead client certification for Masa and server certification for EST at the same time. So remote. So recommend lock NOC certificate for its CA, but for enterprise network, with if enterprise have multiple logs, NOC, so using the three-tier PKI structure to a single location with all, if a single location with all logs for operational continued by installing root CA in several VMs. Three-title KPI is also feasible, but for small homework, three-tier PKI is redundant. Recommend locate on user's own device. Okay, next.
Now on slide 4, just a few seconds.
Yeah. Okay. To register database, it has two data flow, which first request from Pledge to Masa and first return back from Masa to Pledge. So register is the data exchanging center for different use case maybe need to design features calling mechanism completely synchronize operation in the same thread. The whole data place depend on the thread's timeout. If it may be suitable for small home network and completely asynchronous. Part 1 and part 2 are in different process, so there will be a higher latency. But meantime, asynchronous provide secure advantages internal facing ports level context to the internet, then have to less the malicious influence and partition asynchronous register may be suitable for middle enterprise users. This is 3 option calling mechanism. Okay, next.
Click now on slide 5, just a few seconds.
Okay, this 3, the third configuration about ACP addressing based on Brisky IPv6 link local on pledge ACP connection make register must contain a unique IPv6 address for certifications, and the IPv6 address have 2 types: F equal 1 address and F equal 0 address. So limit the loss number when pledge connect at of address. This is ACP addressing for connecting pledge. Okay, next slide.
Click now on slide 6.
Next.
Please wait.
Registers security 2 points need to the internal facing register is LAN network can access a lot of IoT device. If some device exists malware, this will exhaust the bandwidth between join process and the register. The second issue is in home network. In home network, which CA key deploy locally. If CPE fail, the user need to backup database. But for some reason he failed, then he will throw away his CPE. Then this will cause PKI key lost and let his home device lost of control. This is 2 security about the register. Okay, next.
Now on slide 7, please wait.
Yeah, and finally, this slide I want to summarize register consideration. The first one is about certificate issue for different use case. The second is data process mechanism, synchronous or asynchronous is suitable for different use case. The third is about ACP IPv6 address based on device scale, whether recommend F equal 1 for most enterprise and home, F equal 0 for ICP. The fourth is we think about 2 security points, DDoS and loss of key. Besides these 2, maybe there are some major topics. At the end, does some parts or of registers considerations in this draft for fit into IETF and into ANIMA working group drafts. This is our consideration about risky register. That's all. Thank you.
Any questions? Maybe just a quick comment from my side. I haven't been able to get through all of this in detail. The one of these last bullet points here, or one of the bullet points on slide 7. I think that the answer to question number 1 may depend on the use case. So, for example, for ACP, the discussions about whether a public PKI could be used for ACP certificates through Brewski is already in the ACP RFC. That was just all part of the improvements in the last half a year to make that clearer, because we were fairly clear that you need a private PKI, at least from where you start your trust anchors. Now that trust anchor can be signed publicly, but it doesn't need to be and doesn't have a big benefit. But I would guess that depending on how you're using the certificates, and there may be similar answers that we may not be able to give just for Brewski registrars, all the recommendations the same as across all use cases. Any other questions? Right. So yeah. So these polling the audience with respect to who has read the draft and whether you want to have working group adoption. That seems to be something we'll really start to have to figure out better. But please bring up the topic of this draft also on the working group and ask the question if somebody has read it, and please comment on it, or just say whether people have read it, so that we can start vetting the interest of the working group in this somewhat more, right? So please actively drive that for your draft.
This question should be asked by us, the chairs. But actually, before that, we need to say more discussing on this draft.
Exactly. Yeah. Right. Yeah. But as I said, right, on the mailing list, right. So if we see the activity, that it's being discussed and that people have read it, right, it's always easy in the room to do a raise of hand who has read the draft. But I think that right now we're the other virtual interims also didn't feel confident of assuming that this would work equally well in WebEx. So that's a little bit the challenge we'll have to adopt to. And so I think it's even more important for the authors of the drafts to basically raise the activity in the working group about their draft, so that we can do that vetting solely from the mailing list. Okay. So. Okay, so I think Wei, is that you?
Yeah. Can you hear me?
Yep.
Okay, good. I'm Wei Pan from Huawei. This is the operational consideration for Mazda, and here there are two aspects of the relationship between the device and the manufacturer. First is that the manufacturer provisions an identity, aka IDEV ID, for the device. So this device identity is validated by the Mazda before issuing the voucher. The later consideration include the key pair generation and the PKI for IDEV ID. The other aspect is that the manufacturer provides a mechanism. This mechanism will convince the device to trust the new owner. So the device can validate that the voucher is issued by a legitimate master. So, and the consideration include the PKI for master signing keys and some different master types. Next, please.
Rolling to slide 3, and here we are. Slide 3. Okay.
About the operational consideration for IDEV ID, first part is key pair generation, and we think technically there are 3 kinds of generation methods. First is on-device key pair generation and off-device key pair generation, and key pair generation based on our 256 bits. We want to have a better name for this, but maybe later. Next, please.
Rolling to slide 4. And here's slide 4.
Okay. About the on-device key pair generation case, the key generated on the device during manufacture time, and so the private key will never leave the device. And the device conveys public key to the manufacturer, and the manufacturer issues a certificate and records the certificate and returns this certificate to the device. This kind, but their disadvantage is that the device may not have a verified random number generator, so the randomness may not be guaranteed. Next.
And slide 5.
About the off-device key pair generation, typically it is said that the manufacturer generate the key pair and issue the certificate and install the private key and the certificate to the device. The device just needs to store this private key and the certificate. The advantage is that manufacturer infrastructure to generate a better with a private key pair with better randomness, and the authenticity of the public key is also well known to the manufacturer. But the private key is seen by the manufacturer infrastructure, so this infrastructure will becomes a more valuable target. And next, please.
Slide 6.
The third method is that when the manufacturer builds makes the device, and when to use some like silicon fabrication, and this silicon fabrication a unique secret seed, and also this secret key is provisioned to CPU to the device and is revealed to the OEM. So the manufacturer and the device can both generate the key pair, but separately. And the manufacturer, after the manufacturer generated the key key, it will distribute the private key and issue a certificate, and it returns the certificate to the device. So the trust. So in this case, the trust is replaced with a heightened trust placed in the silicon fabrication facility, and the key derivation system can be completely disconnected from the networks because they can both do the key generation without connected to each other, and but this OEM, the manufacturer, must be supplied by a trusted silicon fabrication system with this unique secret seed, and OEM, the manufacturer, must store and care for these keys very carefully, and this will be a burden for the.
7.
Okay. About the PKI for the IDF ID after the key pair generated, and when the manufacturer wants to issue a certificate, a 3-tier PKI structure is appropriate. Maybe someone say this is properly. The EE certificate should not be counted as a tier, but this is the case. The picture below is the case. There, the bottom is a root certificate, and a root CA issues intermediate CA, and the private key of the root CA should be kept offline to provide provide safety. And a number of intermediate CA have the online private keys, and they will issue the IDFID certificates. And they can periodically destroy the private keys and generate a new one. And the entity certificate is the IDFID certificate. Next, please.
Slide 8.
Okay. Next part is about the operational consideration for MRSA. First, there are four types cases, four cases we want to describe. And first is about the multi-product MASA. This case is that there is a offline CA, and the CA's private key is kept offline in the safe, like in some kind of safe in the left box, and it will periodically sign a new entity certificate. This is the MASA certificate. You can see in the middle box, and the MASA use the e-certificates online private key to issue voucher for the device, and you can see our manufacturer level MASA, and the manufacturer may have several product lines, and it will have only one MASA, and this MASA issue vouchers for different types products. Yeah, this is a case. And next, please.
Click slide 9.
Next, this case is our simple enhancement of the previous case. This case has our unique MASA offline key for each product line. So you can see the picture. For product line A, there will be our CA, offline CA, and for and this CA issues our MASA E certificate for the MASA 1. And this MASA 1 will issue vouchers for device which has a common type A, and for different type product line B, there will have our second MASA 2, and our second CA2. So this is the case, and so the private keys are kept separately. So the compromise of a single product line MASA doesn't comprise all products. And if one product line is sold to another entity, and the MASA escrow process affects only this single product line, and the serial number of the products of the device can be duplicated among different product lines. But this requires a private key to be restored for each product line, and but this is a case which we think it is encouraged. Next, please.
Slide 10.
And this case is that also is a per product MASA, but the MASA key is intertwined with the IDFID PKI, which means that the user sends MASA certificate and IDFID certificate. You can see the picture. Our root CA signs 3 intermediate CAs, and the CA1 is for device type A, and the CA2 issues our certificate for device 2, and CA3 issues the certificate for MASA. But the problem is that for device 2, which one is authorized to sign the vouchers, because when you validate the certificate chain, if the device 1 signs a voucher, the certificate chain can also be validated, but the device 1 is unauthorized to sign vouchers. So this is problem that the manufacturer need to consider. Next.
Slide 11.
Okay. Here is that another enhancement is that for each product line, you may have multiple master offload keys. So you can use these keys to in a rotated manner to sign for the device. But this is not very convenient because all of the master signing keys need to be online and available, and we need the manufacturer need to keep track of which device trusts which key in the asset database. Next, please.
Slide 12.
Okay, the final page. We welcome more reviews and comments. And do you think this work fit into the IETF and into ANIMA? And that's all.
Thank you very much. Questions? Am I 15? I don't see anybody in the queue. Please speak up. Go to the next step. It's going to be me. Okay, wanted to give update on the status of the ACP. So around IETF 106, we had version -21. We had gone through the security review by Ben with the RFC 822 name, hopefully having been the only discussed that was kept open. And then a new area director was assigned to the document, Eric Winke, because Ignas, who was the area director at that point in time, had to excuse himself. And because of the term ends of IESG members, IESG reviews expired. So the process that Eric was starting then provide his review, and then second IETF last call, and then back for final approval by IESG. And so basically the review from Eric came in January, February, March. I pushed out 24. In the meantime, since then, I also got the review by Russ Housley I'm still working on, and discussions with IPsec experts, also Michael very much helping on that. Thank you very much. And the document is now in the second IETF last call from Eric. And I wanted to quickly summarize the changes that were done in February, March. So the 822 name discuss is still open. So now Russ has also chimed in with the statement from Ben that using RFC 822 name seems wrong, but fortunately I haven't seen any good, technical support for this. So that's going to be part, I think, of the discussion we need to have. And there is a long section of reasons for doing this choice from a lot of operational reasons in section 612. So I think it would be good to get to that technical level of arguing about the pro and cons. I haven't seen any supporting arguments that there is really anything in an RFC says we can't do it. It was just, I think, other preference choices by the people, and I think the document right now very much reflects the operational preference choices from the working group and the implementations that we have seen. Yeah, so I'll going to finalize that review in the next few days to Russ and try to upload to 25. There is also some of the IPsec discussions that we had. There needs to be very careful removal some of redundant text that we had about refining the profile versus the IQ2. So I didn't want to rush that to make sure it's done correctly. So the major changes from 21 to 24 beyond these open issues So I hope that the overall security section for the secure channels is a lot more well structured, because I've pulled out what really is applicable to all secure channels from the IPsec section. So things like that there is no MTI protocol, that the security for the weakest link is what determines the security of the overall ACP. So there needs to be a common lowest common security level across all the secure channel protocols being used. And these points that we can reuse physical link security or reuse existing L2 encryption if available. So that's basically to these common requirements: forward secrecy, suggested lowest common denominator of security for the data packets AES 256 actually, sorry about that. Explicit closure of the channels upon authentication expiry, right? If certificates expire, the secure channels need to be closed. And then also the suggestion to create strict profiles for any new channel protocols, because, and that's what we've went through in IPsec, the current profiles very often have a lot of legacy in them that really would make implementation hardware forwarding quite complex if you start new, right? If you have old implementation, of course it's fine, but we want to enable new players in the market to implement ACP in hardware, then basically we need to make sure that we do as little as possible requirements, right? And there is no interop requirement with older stuff whenever we do it. So that basically leads to the IPsec profile, which is split up in between the ESP profile actually for the forwarding plane, which based on 8221 RFC. So I'm not going to go through the details there, except saying that there's a single MTI mechanisms and discussions on how there is a should based on performance for the others. Now on the control plane, sorry, there's another typo here. The IQV2 BCP RFC, that specification primarily says to use ACP certificates, how to put them into the IQV2 signaling, and must use digital signature. So that's basically where I think there's some additional text that we have there that needs to be stripped. But overall, we're not really trying to, not mandate anything that's in 8221, because it still seems that simply reusing any existing software implementation, however many options it has, is the safer starting point than trying to come up with more strict profiles, and it doesn't have a performance impact like in the data plane with ESP. There's a new section on the real-time clock, so that was pretty much stolen from Brusky and just adopted, and effectively, there may be, issues when you do not have a real-time clock and you do start with just, trusting that certificates presented to you are valid because you don't have a better clock, and then going back to actually getting trustworthy clock through the ACP. So this section now writes this down. DTLS, secondary ACP channel protocol. So this was very much upgraded to mention DTLS 1.3 once it is in RFC. So because we really don't benefit a lot from any DTLS 1.3 improvements, the profile already is fairly close to DTLS 1.3 from the security sides. And we don't really want to blocking against DTLS 1.3, but there is an RFC author note that will change this to be a must for DTLS 1.3 once there is an RFC before we're in auth 48 for the ACP. And the main reason, of course, is that we can't simply strip out DTLS 1.2, because in the space of routers firmware of devices where we want ACP implementations, the prediction is very easily that DTLS 1.2 will probably stay the only available software for a longer time than we see that in, let's say, the space of web applications. Similarly for TLS, which is used end-to-end for securing grasp inside the ACP, must TLS, should TLS 1.3, small limited profile of crypto. And so the goal for the profile was already to be as close as we can with 1.2 to TLS 1.3 without expecting that all ACP devices support TLS 1.3. And hopefully, you know, that would be faster to recognize when TLS 1.3 is expected to be available across all the candidate ACP devices, and always a reminder that in an ops group, you know, trying to stick to the standards that we have that are widely available is, you know, something of the pragmatic compromises that, you know, in ops are quite important. Ripple, yeah, hopefully good, you know, improvement on the text of all these Ripple data plane artifacts. You know, if you know something like SRv6, Ripple has multiple of those, so that was confusing to Eric and to me as well on the text side, because the drafts were kind of confusing. There is an improvement on the to better explain how the secure channels, the secure associations are mapped to the virtual interfaces. And then there was a rewrite of the ACP over L2 section, because I think there was very little, if not none at all, review of that section before Eric. And so the whole idea was to explain how it's easy on a layer 2 switch to implement the ACP, at least in software, without any new hardware forwarding requirements. And that's purely done through, you know, doing the right thing in GRASP, and therefore allowing a software ACP in there. And then added requirements for filtering of these data plane artifacts on ACP access nodes. So those were just, you know, cool functional improvements that were there. There was a really very good review from Eric with a lot more textual and structural and other improvements, but I didn't want to bother the time here of the working group with that. So thank you very much. Any questions on this?
Teres, this is Shin. I do have a actually management question. Earlier you mentioned because the term of AD, so we actually lost some positions. For now, it seems we are short of at least 7 positions. I mean, we were there, had enough position, but since those ADs stepped down, so we lost their positions. Does that means we are going back to the ISG meeting again to get the more position from the current ADs, or what we need to do?
My question is the same, and it's actually kind of more to Russ, Housley, Eric, and Rob, who is this. I noticed that quite a number of people, ADs, gave us no objections, or we have no record even from ADs that are not new, and therefore we effectively have one yes from Terry that we need to replace and one discuss. So it seems like 15 ADs have basically said they're just leaving it to the one discuss, and that's it. And I just don't understand if that's a typical thing now in the IESG.
So this is Eric Ving speaking here. So it's not the first document that's coming back after 1 year or 2 years, and of course IESG members have changed. It vastly depends upon the change of the document. If the document has been just changed, I don't know, 5–10%, not a lot of things change, we simply come back in front of the telechat and people may change their point. And of course, people that are not there or cannot change or they don't count, and new ADs can vote on this. But in this case, pretty much like I have asked for a second last call, because the document has vastly changed, and thank you again, Teles, for addressing all those comments and working on it. It will come to another ballot, starting from scratch.
Yeah, but
so basically forget about the last one, and then the new one is coming.
This is not rough consensus. This is one veto, because there are no yeses. And
yeah, Michael.
So that's
this is Russ.
Michael, there will be a new ballot. There will be a new ballot, And as I'm the responsibility for this one by historical reason, I will obviously, as soon as the last call is finished and we all agree that we need to go forward, I will vote yes. That's the usual procedure. So you will get one yes, mine, at least.
Michael, this is not unusual. This is Russ Hasley. It's often the case when a second last call is asked for, that the ADs will throw away the old ballot and then do a new one based on the second last call.
Okay. Any more? And by the way, there is in the in -21, I removed the whole changelog, which was already 20 pages long, and did a summary of what was changed from you know, the start of the IESG process to the end of the IESG process. I hope that people trying to review the difference will get a fairly good summary, except that from -22 to now, there are still more detailed differences. Okay. So 9:59. Not looking on the watch actually helps to stay in within schedule. Interesting. Any last closing word, Sheng?
Not from me, but I mean, I'm not sure when we'll have the next meeting. Will that be another intermeeting online, or you know, we are scheduled for the next IETF in where?
Yeah, I think
Madrid.
my suggestion would be if basically authors of certain documents feel that there is enough to discuss on the content of documents, please bring up that suggestion. We can always have interims, and the more we're training virtually, the more helpful. So I think as working group chairs, we're very happy to set up interims for this. This is still using all the interim tools, and then I think we'll wait once we get closer to Madrid, what the plans are for Madrid, and accordingly plan for that, which probably will be a virtual meeting as well, right? Okay. Thank you very much. If anybody has missed to sign the blue sheets in the Etherpad, please do this now. Still open, and then see you next time. And any author, please have your work actively discussed on the mailing list. Thank you very much for attending.
Thank you all, guys. See you next time.
Thank you. Bye-bye.
Bye-bye.
Happy Easter.